Hello, in this lesson, we're going to learn about simple interest and the future value of simple interest using what we know about percentages. Using percent is going to be kind of a recurring theme throughout mathematics, so you might as well just go ahead and get comfortable with percent. Before we get into percent or using percent to solve problems, let's talk about a few key terms that are involved with finding interest or simple interest in this case. The principal, we're not talking about the principal of a school, we're talking about a principal amount. This is referring to the initial amount or the starting value or maybe the loan amount. So let's say you bought a car and the price of the car would be the principal amount. And then if you borrow money to pay for the car, then whatever institution you bought or borrowed money from is going to charge you an interest rate on that loan. So they're not just going to lend you money for the sake of lending you money. They're going to make money off of what you borrowed. And this is based on an interest rate. And an interest rate is expressed as a percent. And we will convert that to decimal form in order to solve the problem. And then interest, this is referring to an interest amount. This is a dollar amount based on the interest rate and principal, actually. And then simple interest versus compounding interest. We're actually not going to explore compounding interest in this lesson. I just want to kind of introduce you to the difference there. Simple interest is more simple. It's an interest amount added each year. Whereas compounding interest is like, compounding means it's being added over and over and over again. So if you have an investment and it sits there for a year, then it's going to have interest earned on that investment, or it might be spread out over twice a year or monthly or whatever, but compounding can be several times a year. And then whatever new amount is sitting there will get interest will be put on that again, and then again and again and again. And so it grows exponentially. It grows faster and faster and faster because it's compounding. So kind of like with a credit card, whatever amount is sitting there that you don't pay off is going to have interest on it. And so that's going to be added to your next bill. And then whatever builds up over there is going to have interest added. And it just kind of gets bigger and bigger and bigger. So it's kind of like that. Simple interest is a constant amount added each year. And compound interest is interest applied up to several times a year based on the previous amount. So they're different in the sense that this is going to be a constant amount each year is going to be more of like a linear type function. And then compounding is going to be more of an exponential type function. You don't have to worry about that necessarily for this lesson. I'm just trying to show you the difference. So we are just looking at simple interest today. And to find simple interest on a principal amount, it's a very simple formula. It's I for interest equals P times R times T. When variables are written side by side like that, it means multiplication. Where P stands for principal, R stands for rate, and T stands for time in years, which is important depending on what they give you. It will give you the amount of interest added onto your principal amount. So for example, we're finding the simple interest paid to borrow $5,675 for 7 months at 6% interest. There's key information here that we want to pay close attention to that is going to set up our equation. We're talking about the simple interest, which is a formula where we need P, R, and T. And oftentimes it's going to help to go ahead and just rewrite that out. P equals 5,675. R is a rate as a decimal. And T is supposed to be a time in years. We were given it in months. So we're going to have to convert that to years. If we're talking about part of a year, so 7 months out of 12 months, we can write that as a fraction, 7 out of 12. And then you can get that in decimal form if you want to. I'm just going to leave it as a fraction so that I don't have rounding error. And now I just plug it into my formula. P, R, T. And then multiply it out. We've got, let's see, P times R times T, which is a fraction. And we get $198.63. I rounded up because the 2 has a 5 behind it, so you're going to round up. And it makes sense to go to 2 decimal places because we're talking about money. So this is the interest amount. That's not the only thing that has to be paid back. If you borrowed $5,675, that has to be paid back. And this interest amount also has to be paid back. It all has to, which means that if you're looking for the total amount to be paid back, you have to do the principal plus the simple interest, which we found to be $198.63. And we would get a total of $5,873.63 total to be paid back. This amount to be paid back is called a maturity value. So our loan has matured to this amount. And we generally refer it to, you're going to hear me refer it to as future value. So when I say, what is the future value of this loan? I'm talking about the total amount. And then the interest amount on the loan was this smaller dollar amount. So let's use that to talk about the next thing, future value. We've already found future value. We just broke it up into 2 pieces. And when we did that, what happened was for our future value, we'll call it capital A amount. I don't know. We took our principal, I did lowercase principal, and we added simple interest. Now, these 2 terms share a P. And so sometimes you'll see this written out as P times 1 plus RT. What happened there is that we factored a P out of each term. You don't have to know how to factor. Either one of these formulas are the exact same. You'll get the exact same value, so you can use either one. I'm happy with both. I really do not have a preference. So either one, this one, or this one will give you future value on simple interest. For example, find the future value of a deposit with simple interest of $3,500 at 12% interest for 10 years. So we know that the formula for future value is either one of these. And we also know P, R, and T. So now we have everything we need to plug into the formula. Now, let's think about this for a second. We've got this initial amount, and then we have a simple interest on this principal amount. So each year for 10 years, we're applying a 12% interest rate. And that's why it's being multiplied here. The principal times the rate times the time. We're multiplying it by 10 years because it's adding that interest. After the first year, you get 12%. After the second year, you get 12%. Third year, fourth year, fifth year, sixth year. And we end up adding it on 10 times, thus times 10. Isn't that cool? So the longer you leave it in there, the more interest you're going to have on your principal amount because it's gaining interest each year that it's sitting there. And then even further than that, compounding interest, it's growing exponentially because after the first year you have an amount, and the next year the interest is based on, or the next time it compounds, the interest is based on that new amount. And so then now your bigger amount is growing to be bigger, which is growing to be bigger and bigger and bigger and bigger and bigger. It's called exponential. So anyway, sorry for the nerd rant. Moving on, it does apply to this lesson, but I just kind of wanted to show you where that formula comes from and why it works out the way it does. And so we can take our information, plug it into either formula. It's being has an interest of 12% 10 times because it's 10 years, or our other formula, 12% 10 times. And we are going to end up with the same amount no matter which formula we use. And I'll show you, plus 3,500 at 12% for 10 years, or 3,500 first year plus 12%. There you go. 7,700. Doesn't matter. So if this amount sat in an account for 10 years, then after 10 years, when you come back to that account and you withdraw money, you would have $7,700 sitting there just for money just sitting there. Isn't that amazing? I love that. It's not amazing if you have to pay it back. Loans are no fun. So the total amount, the future value, was 7,700, which means that we can use that to find how much interest was gained on this principal amount. Now, depending on which formula you use, you could see that right here. This was our interest amount. So you could just use that simple interest formula and multiply it out. Or you could take the the future value and subtract your principal to figure out that difference between the two. Whichever one you use, you should end up with $4,200 in interest. That's a lot of money for it just sitting there. All right, that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help. See you in the next one.